Okay, so now we are going to look at hypothesis of parametric testing, and we are going to look at the general assumption. The general assumption in terms of the parametric testing, one, there should be normal distribution of the data. There should be no significant outliers. And there is homogeneity of variance, and then independence. So now let's just look at how are we going to determine the normal distribution of data. We determine there are two ways of checking whether the data is statistically or is normally distributed. Number one, we have analytical method. We have analytical method of checking the normal distribution of data. Then apart from analytical method, we also have graphical methods. We have graphical method of checking the normal distribution of data. So now we are going to look at this method of determining the normal distribution of data. Okay. So now for the analytical method, we have three major ways. We have Kolmogorov-Simonov tests, we have Sparrow-Wilk tests, and we have Anderson-Darling tests. So based on these three analytical methods, you can check the normal distribution of data. So if you actually obtain, when you have your data and you input your data either in SPSS, Excel, or data type, we are going to obtain a table, and this table will comprise of these three analytical methods, which is Kolmogorov's, Simonov test, Sparrow-Wilk, and Anderson-Darling. So if you actually plot if you obtain your table and you are able to observe that your phi value, if your phi value is less than 0.05, if it is less than, that is smaller than 0.5, then it means that the data is not normally distributed. But if it is greater than 0.05, it means that the data is normally distributed. Like for example, look at it, a phi value smaller than 0.05, no, it means normal distribution is assumed. So it means that the normal distribution is not assumed. But if it is greater than 0.05, it means that the normal distribution is assumed. So this is one of the first methods we use in determining the normal distribution of data. And then apart from this, we also have graphical methods. And this graphical method comprises of histogram and quantile plot. So you see, this is when you plot your data and you obtain your histogram, then you are going to, for you to check your data, you have to make sure that it is normally distributed. And how do you determine the normal distribution of data is when you have a bell-shaped histogram. Look at it here. This is a bell-shaped histogram. You can see it here. This is the histogram. And then when you draw this, you have a bell-shaped histogram. So that indicates that the data is normally distributed. But in the case of quantile plots, the dots, all these dots must be aligned within a single line. So when you have something like this, it indicates that the data is normally distributed. So this is actually 5 ways in which the normal distribution of data is determined. And number one, as I said, we have analytical. So under analytical, we have 3 methods. And then for the graphical, we have quantile plot, and histogram. Although there are some limitation of using analytical method, because analytical method depend on the sample size. Because if your sample size is very small, there is a likelihood that you may not actually get the desired result. And the distribution of the population deviates slightly from the normal distribution, especially if the sample size is very small. So this is the way of determining, or these are the method of determining the normal distribution of data. Okay. So now I think for this is clear, and now going to make another video of how to get this data. Okay.